In this video, let us look into the frequency distribution. Let us see what is frequency distribution and the different types of frequency distribution. Now, the frequency table or the frequency distribution is a method to present raw data in the form from which one can easily understand the information contained in the raw data. Now, frequency distribution are of two types. Now, the frequency distribution are of two types. The first one is discrete frequency distribution and the second one being continuous grouped frequency distribution. Now let us look into the discrete frequency distribution. The process of preparing this type of distribution is very simple. The construction of a discrete frequency distribution from the given raw data is done by the use of the method of tally marks. We've already seen what this means in the previous videos. We just have to draw some bars, that is the vertical lines, and when we draw 4 of them, we just need to draw the 5th one across them and make it one group. So that means it is equal to 5. And then in the next column, say for example if it is number of students, then it is understood that the number of students is 5. That is corresponding to that striked across tally marks. In the first column of the frequency table, we write all the possible values of the variable from the lowest to the highest. If we compare the last sentence to the previous videos when we looked into or when we did the grouping of raw data, we did come across the term variate and we linked it to the marks because the marks were differing. That is, it was varying 1, 3, 5, 8, 39, 23, 21 and so on. So that's what this means. In the first column of the frequency table, we write all the possible values of the variable form from the lowest to the highest. So this is a discrete frequency distribution. Let me give you a quick example for a discrete frequency distribution. So here, a quick example of a discrete frequency distribution. The question here or the data here is, or the statistical data here given is, the number of children in 20 families are 1, 1, 2, 3, 4, 3, 2, 1, 1, 4, 5, 2, 4, 2, 2, 1, 3, 3, 2, 5. So these are the number of children in 20 different families. Now let us construct a discrete frequency distribution for this given data. So here is the discrete frequency distribution for the above statistical data. As explained in the previous sheet, the first column consists of the variables from the lowest to the highest order. That is, the number of children is a varying thing here. So the different number of children the 20 families have are 1, 2, 3, 4 and 5. But how many families do have just one child? So we first have to count it in terms of the tally bars. We first count 1 and then draw one vertical bar. So this is 1. The next one is 1. So we draw another vertical bar. The next one is here. We draw another vertical bar. The next one is here. We draw another vertical bar. And the last one is here, which is a 5. So we cross the whole thing. So this means 5, which is mentioned here in the frequency. So similarly, we do likewise for, now let us see the number of families that have 2 children. That is 1, 2, 3, 4, 5, 6. So here we are 1, 2, 3, 4. We cross the bar. That becomes 5 and then one more 6. So here it is 6. So all we need to do is write the variable in the first column, the bars in the second column, and the frequency in the third column. So this is how we construct a discrete frequency distribution. Now the second type of a frequency distribution is continued or grouped frequency distribution. Let us go into that in the next sheet. Now let us understand what is continuous or grouped frequency distribution. Now in the previous sheets of which had the method of condensing the raw data as convenient, only when the values in the raw data are largely repeating and the difference between the greatest and the smallest observations is not very large. As you saw the last time, the minimum number of children were 1 and the maximum were 5. So hardly they were like 1, 2, 3, 4, 5. But when we come to the continuous or the grouped frequency distribution, the difference between the greatest and the smallest observations are very large. Let us quickly look into an example. Now, let the marks obtained by 30 students of a class in test be 39, 25, 5, 33, 19, 21, 12, 48, 13, 21, 9, 1, 10, 8, 12, 17, 19, 17, 41, 40, 12, 46, 37, 17, 27, 30, 6, 2, 23, and 19. Now, arranging this in the discrete frequency distribution is not very simple. It does not solve the purpose of making this further simpler, because the difference between the lowest variable and the largest variable is not very small. So this is when the continuous or the grouped frequency distribution comes into play. Now let us see how we can arrange these marks by the method of continuous or grouped frequency distribution. Now here we have the representation of this given data in the method of continuous or grouped frequency distribution. Here what we're doing is the different marks, that is out of 50, varies from 0 to 10, although we do not have 0 in this list. That is how it is. There is a possibility of somebody scoring a 0 and also a 10 and also a 30, 40 and 50 and so on. That is between 0 and 50. So we group the numbers between 0 and 50 in terms of 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Now we count the tally bars or make the bars for the number of marks that is between 0 and 10. Between the marks 0 and 10, we've got 1, 2, 3, 4, 5 and 6. So between 0 and 10 also includes 10. Now let me come to this. Now if you consider the way we've split this, it is 0 to 10 and 10 to 20. So what does it mean? Now where do we write the marks of 10? Do we write it in the first row or the second row? I'm coming to that in the forthcoming video. But here if you see, the number of students that have got the marks between 0 to 10 are 6. Now let us count that from here. 2 is 1, 6 is 2, and then we've got 1 is 3, and then 5 is 4, and then 9 is 5, and 10 is 6. So here it includes 10. Now let's leave that now for a little later, and let us finish this. So this is how we write the bars, and then the number of students getting the marks between 0 to 10 is 6. Similarly, between 10 and 20, there are 11 students, those who've got the marks between 10 and 20. 20 and 30, 5 students. 30 and 40, 4 students. 40 and 50, 4 students. So this is how the continuous or grouped frequency distribution is constructed. Now let me deconstruct the whole table of continuous or the grouped frequency distribution for you. Now these groups, the 0 to 10, 10 to 20, are called classes. The class 0 to 10 means the marks obtained between 0 and 10, including 0 and excluding 10. This is the most important point here. It is excluding 10. The number of observations falling in a particular class is called the frequency of that class, or class frequency. Thus, the class 0 to 10 has a frequency of 6, and the class 10 to 20 has 11 as class frequency. In the class 0 to 10, we say that the 0 is the lower limit and 10 is the upper limit of the class. Similarly, in the class 10 to 20, we say that 10 is the lower limit and 20 is the upper limit. So the span of the class, that is the difference between the upper limit and the lower limit, is known as the class interval. For example, the class 10 to 20, in the class 10 to 20, the class interval is 20 minus 10, which is 10. So that is called as a class interval. Now, there are two methods of classifying the data according to the class intervals. That is exclusive method and inclusive method. Now let me quickly show you an example to distinguish exclusive method and inclusive method in the next sheet. And a quick clarification here. I was counting 10 for the class interval 0 to 10, but then it is not, because if you see, we've got 5 here, which is 1, and then we've got 9 here, which is 2, 1, which is 3, 8, which is 4, 6, which is 5, and 2, which is 6. So we are not including 10 in 0 to 10. So this is an example for exclusive method. Anyways, I will show you a clear difference between the exclusive method of class interval and the inclusive method of class interval in the next sheet. Now here we have an example to illustrate the differences between the exclusive method and the inclusive method of class intervals. It is evident from this example that both the inclusive and the exclusive methods give us the same class frequency, although the class intervals are apparently different in the two cases. In this example, in the case of exclusive method, the class interval is 100, if you see, whereas in the case of inclusive method, the class interval is 99. That is, 1100 minus 1000 is 100, and 1099 minus 1000 is a 99. However, 99 is not the correct class interval. Whenever the inclusive method is used, it is necessary to make an adjustment to determine the correct class intervals and to have continuity. So if a minus b is a class in inclusive method, then in exclusive method, it becomes a minus h by 2 minus b plus h by 2, where h is equal to lower limit of the class minus upper limit of the previous class divided by 2. So here, if you can clearly see that in the exclusive method, the 1100 is not included in counting the number of workers. So in the inclusive method, it is very clear that it is already mentioned only till 1099. So this is the difference between exclusive method and inclusive method.